Good morning, students. Let us consider two very important concepts as PDF and CDF under probability and random processes, unit number 6, which we have studied. So, under that, probability density function is one of the important parameter in the analysis. So, briefly, we will take what exactly it is, and then we'll solve one example. Probability density function is the derivative of cumulative distribution function, that is CDF. So fxx, as you can see, is equal to ddx of fxx. So this is our density function, and accordingly we need to calculate. Now it can be derived for discrete as well as continuous time random variables, and it describes continuous random variable in better way as far as its utility or actual application is considered. Now, as far as its properties are to be considered, then first thing is this is integration of PDF, as CDF is integration of PDF. The way we define PDF is derivative of CDF, so similar fashion. Then fxx is equal to d dx of capital Fxx. For all values of x, it is always greater than 0 or equal to 0. So it is never negative. CDF is an increasing function, and the derivative of an increasing function is always a positive value. Area under PDF curve is always 1. So theoretically speaking, over minus infinity to infinity, fxx dx is always equal to 1 over the entire period. Then if we integrate and then if we find out, so at the conditions, as fx at infinity is always 1 and fx at minus infinity is 0. So fxx dx is 1, which is the area under PDF curve. During calculations, say for example, one example here we are considering, fxx is equal to 0 for x less than 0 is equal to kx square for x greater than 0 less than 10. Now the question is determine k, and one more consideration is fxx is equal to 50 for x greater than 10. So these are the say conditions which are to be here while solving that, which are to be taken into consideration, and we want to determine for p, x is in the range 2 to 4 and p for the range x less than or equal to 5. So for both these cases, if we calculate, then you can see here, first of all, fxx is equal to 50k, which we can write for x greater than 10. So as far as per our definition, and we know that 50k is equal to 1. So therefore fxx is equal to 1 for x greater than xn, and k is equal to 1 by 50. So here if we equate this one is equal to 1 for x greater than 10, then by default k will be equal to 1 upon 50. So this is the first thing. Now PDF we want to calculate. So fxx is equal to d dx of fxx for x greater than 0 less than 10. Now that will be d dx of kx square, which is equal to 2kx, which is equal to 2 into 1 by 50. So it comes out to be, or if we write it as it is, 2k into x, that is 0.04x. Now for condition 2 to 4, it will be upper limit is 4. So fx4 minus fx2, we are differentiating it over the given interval. So 4 and 2, upper is 4, lower is 2. So this will be kx square for x is equal to 4 minus kx square for x is equal to 2. So we can write this as per whatever values we have. So this is 0.02 into 4 square minus 0.02 into 2 square. So that comes out to be 0.24. And for x less than or equal to 5, p x greater than 0 less than 5 is equal to fx5 minus fx0. fx5 is kx square, that is 0.02 into 5 square, and fx0 is 0. So therefore answer comes out to be 0.5. So this way you can solve for the simple calculation. So you can see here the given data, and accordingly probability density function you can estimate. So carefully see here how it is done. Taking difference based on the interval given is the simplest way of calculating PDF. Okay.